Hello everyone, it's Mrs. Wallace. How are you? I just wanted to do this quick intro to elasticity for you, just to get you started on some of the content in case you're not taking the quiz today. A little bit about elasticity. It relates a lot to supply and demand, so it's kind of an extension of some of the things we've been working on in class. Elasticity comes in a lot of different types, so economists love elasticity. It helps us understand the relationship between variables. If given a percentage change in one variable, what is the percentage change effect on another variable? So economists use elasticity all the time. We will look at 4 different kinds of elasticity. This is mostly about price elasticity of demand. That's the first elasticity that we look at, and it relates very much to the demand curve. So here's our downward sloping, downward sloping demand curve. Here's our downward sloping demand curve. Remember that on any given demand curve, we have a series of points, okay? And the points are telling us at particular prices, say P1, we have a quantity that's demanded, let's say quantity demanded 1, and then if we lower the price to P2, we have an additional quantity that's now going to be demanded, a greater quantity when we lower the price, quantity demanded 2. And this just kind of reminds us that the law of demand is when price increases, quantity demanded decreases. When price decreases, quantity demanded increases. What we didn't get from our lesson about the law of demand is, how much. If the price increases 10%, how much does the quantity demanded decrease? We know it's going to decrease unless there's certain criteria in place, but for the most part, it's going to decrease. How much is that going to happen? The same thing if price is decreasing. Will quantity, the effect on quantity, be a very big effect or not so big of effect? And if you are a business, you're very interested in this. So one of the things you can do is check out the 2 articles that are on Schoology. One of the articles is about last year why businesses are obsessed with elasticity, and because of a time of inflation that we're in, we're seeing higher prices. So lots of businesses don't have a choice but to increase prices in order to cover costs, but if they increase prices, it also can affect their quantity that they sell. So if you raise the price just a little bit and nobody buys it anymore, there's really not that much benefit to a business of increasing the price. So because of the law of demand, we're very interested in what happens when we increase or decrease the price a certain percentage. What is the reflecting quantity effect? Okay, so that's what price elasticity of demand is going to be about. We can look at an example, and you can brainstorm this and we'll talk about it in class. So, jot some things down from the 2 articles that are on Schoology. One is about Coca-Cola, the business of Coca-Cola, which did start to increase its price and people kept buying it. So, why does that happen? What does that tell us about elasticity and what it means? The other article is about firms that are very interested in elasticity. And so the article highlights a lot of different firms. Another example that we can look at is Starbucks. And, some of you may go to Starbucks, some of you may not. You might think it's way too expensive. So you're, kind of making the case then that, if the price goes too high, some people are just naturally going to say, nope, not doing that. My husband, for example, I will sometimes get him to go to Starbucks, but he thinks it's like, kind of a ridiculous price and would much rather go to 7-Eleven or something like that. But if you worked for Starbucks, so your job was to actually try to increase the revenue at Starbucks, and revenue is the money that Starbucks brings in. This is not the same thing as profit, because if cocoa bean prices end up being really expensive, that can have an effect on Starbucks' profit, even if their revenue never changes. Revenue is distinctly quantity times price. So when you think of that law of demand, right, if you are a firm, you're saying to yourself, I kind of want, the highest price possible way up here, but, I also want a really, really, really high quantity because that's where, my revenue comes from. So if you start to increase and increase and increase the price, at a certain point, if your quantity starts to decrease, you're going to pay attention to that because it affects your bottom line, okay? what questions might you have if you were going to make recommendations to actually increase the peppermint mocha? So, what are some things that you might consider? Like, first of all, is now a good time to raise the price of a peppermint mocha? Well, it's December 1st. It's into the holiday season. Maybe somebody's going to drive home today and feel like, hey, it's Friday. I'm going to have a peppermint mocha, feeling the holidays a little bit. Maybe a seasonal thing. Maybe it is going to increase for that reason. And maybe come, July, maybe $6.95 for a peppermint mocha isn't going to go down so well. But there are other considerations too, and some of these considerations might be how the peppermint mocha is advertised, what types of products people also buy with peppermint mocha, their complementary goods that Starbucks knows the price increase may cause some people in the market not to buy it. May they also not buy, the candy cane graham crackers or whatever else there might be at Starbucks that goes along with peppermint mocha. And there's a couple of other things that you might consider. So, in your notes, just kind of jot down some ideas. What questions might you have for Starbucks before you made recommendations? If you were going to jack up the price of the peppermint mocha, what might be some things data-wise that you would want to know, right? So think of it kind of like that. And as you read those various articles, you can get a sense of how elasticity is important to firms, right? And attach it to this idea of revenue, which essentially reflects, the sales that Starbucks has of peppermint mocha, okay? They're trying to raise the price as high as possible without affecting the quantity that much, okay? By putting our products into categories. Some products have elastic demand, some products have inelastic demand, and specifically we're talking about an elasticity called the price elasticity of demand. It is specific to one demand curve, okay? And it very much relates to the law of demand. If we increase or decrease price, how much do we have a quantity effect? Is the quantity effect greater than the price effect? Is the price effect greater than the quantity effect? With elastic demand, and think of like a big rubber band that you can pull and pull and pull and pull, elastic demand, we have a lot of price sensitivity. If we increase or decrease the price just a little bit, maybe like 10% price increase, you might see the quantity demanded fall dramatically, maybe like 60%, okay? Elastic demand, very sensitive to price changes, massive quantity effect as a result of a percentage change in price. Inelastic demand, we have price insensitivity, okay? So inelastic demand, for example, if somebody was taking a daily prescription that they really needed, maybe somebody who's diabetic, who's taking insulin daily, and maybe the price of insulin were to go up 10%. That individual who really needs that good, right? Or gasoline, for example, even when it increases in price, we tend to continue to buy it, at least in the short run. In the long run, maybe we get a different car or something like that. But in the short run, you got to get to work, you got to go to your college visit, whatever it is, you need to have access to that gasoline. So you're going to buy it, even if it goes up 10% or 20% or maybe even 50%. In this case, inelastic demand, insensitive to price changes, price insensitivity, and we can see a very small change in quantity as a result of a percentage change in price. This doesn't mean that the law of demand doesn't apply in inelastic demand. In most cases, it's still going to be an indirect relationship. When price goes up, quantity demanded will go down. It's just that the degree of the quantity effect is going to be a smaller percentage than the percentage change in price. Whereas in elastic demand, it's the percentage change in quantity demanded that's going to be much greater than the percentage change in price, okay? So we're able to classify things. And oftentimes, we can look at elasticity as having a little bit of context around it. If I'm driving home from BCA and I know that I want to get my family some milk and I'm late and I'm rushing and I want to get home, I might skip going to like a large supermarket where I have to park and kind of get involved in a much longer visit. I might pay a little bit more to get a gallon of milk at like a Wawa or something like that because it's right across from my house and it's a lot easier to get in and out. And it's also like a dollar, it's a small amount of money, so I might justify inelastic demand because I'm in a hurry. Another day where I'm like going to be buying lots and lots of food, I might not go to certain stores because the expense, now I'm a little price sensitive. So, the same consumer can have a variety of different relationships with a product depending on the concept, right? And if you're looking at this from the firm's perspective, sometimes a firm is very interested in grouping customers in a market based on their elasticity, and they often get us to advertise this. So, coupons serve this purpose. If you walk into a restaurant, with a coupon that says, you're going to get $10 off your dinner, you're basically wearing, a t-shirt that says, I am price sensitive, and you have, suggested you are price elastic. If you are a person who's buying an airplane ticket, like my kid is coming home for the holidays, is looking to buy an airplane ticket, she is a customer who's price sensitive. And so there's certain types of flights that she's kind of directed to because those, are the flights where there is some kind of availability for price sensitive consumers. She's going to fly at 4 a.m. or something like that. Business class, where the business is paying for the airline ticket and somebody's got to go in the morning and somebody's not paying for it, their firm is, a lot less elastic, much more inelastic demand. So, airlines take full advantage of that and have a variety of ways to ensure that they can get the most revenue. So getting a lot of revenue from people who are willing to pay a higher price, right? Take advantage of that demand curve. If you are the firm, you want to get some, consumers to pay as much as they're willing to pay. If they're not price sensitive, we don't want to ask them to be, okay? And that's kind of the nature of elasticity from the firm perspective. The way that we look at this, the formula. So we'll do this, and then this will be like the last thing. The formula is very much the formula for price elasticity is percent change, okay? We're going to be looking at whether or not the coefficient is greater than 1. So this is going to be pretty straightforward. It's percentage change in quantity demanded in the numerator over percentage change in price. So if the quantity effect, the percentage change in quantity, is greater than the percentage change in price, so let's say the price goes up 10%, and the quantity demanded goes down, which we know it will because it's the law of demand, it goes down like 60%, okay? We can tell that this is going to be elastic because the quantity effect is massive and the price effect is smaller, okay? So this is going to have a coefficient that's going to be greater than 1, and that's going to tell us that the quantity effect is greater than the price effect. If we had had a situation where it was the opposite and maybe the price increased 60% and the quantity decreased, but only decreased 10%, then we would know that this would be inelastic demand, okay? So at the heart of this, you're looking at percent change, okay? We can use percentages for a couple of reasons. One is it's a unit-free measure. Remember that we're dealing with a graph that might have any number of units on it, large units, small units, and so the numbers themselves could be really difficult to work with in order to compare and contrast different elasticities. So percent change is something that's going to be consistent. We can compare elasticities across a variety of different products. We also are going to be using the absolute value because the law of demand tells us that if the price increases, quantity demanded is going to decrease, and if the price decreases, quantity demanded is going to increase. We're always going to get a negative coefficient, let's say a coefficient of like 3. We're not interested in the negative sign because then you get like, oh, what's bigger, -3 or -2 or whatever. Just use the absolute value, okay? So 3 is bigger than 2, whatever. We're interested in the degree of that relationship between percentage and price. And the last slide, we'll kind of look at the last 2 slides. This is a example of a demand curve. And on any given demand curve, okay, there's going to be sections of a linear demand curve that will be elastic and sections of the linear demand curve that will be inelastic. And the reason for that is because, we have numbers on the X and Y axes that closer to the origin are much smaller, and then farther away from the origin are much greater, right? So if you're at point A, you might get, a percentage change in price that could be, smaller, but your percentage change in quantity might be pretty big because you're kind of close to the origin on your x-axis. So depending on what the numbers are, it's likely that somewhere you're going to have an elastic range, and somewhere you're going to have an inelastic range. So you can't, and I'm showing that there is a range, and there will be a point that's going to be unit elastic, where the percentage change in quantity is going to be exactly equal to the percentage change in price. We would have to do the math to figure out where along this linear demand curve you might actually have elastic or inelastic quantities, okay? So I'm not doing that math this second, but just giving you the sense that in a linear demand curve, you're going to have changing elasticity, okay, which is very different than slope, by the way, not the same thing, so don't get it confused with slope. But we have a changing elasticity. One method we use is to look at elasticity between 2 points, right? So, if I had a price of $10, right, and now I'm going to lower the price to $5, okay, now I can see, well, what happens to quantity when I do that, okay? So I'm going to be interested in, as a result of a price change from $10 to $5, what will be the percentage change in quantity, and will the percentage change in quantity be greater than the percentage change in price, or will the percentage change in price be greater than the percentage change in quantity? We use a formula called the midpoint formula to figure out percent change. If you're given percentages, right, you can always work with percentages, percentage change in quantity demanded over percentage change in price. If you have a word problem that says, well, the quantity demanded increased by 60% and the price decreased by 3% or something like that, we know we're going to have, or say 30%, we know we're going to have an elastic coefficient. But when we have numbers on our x and y axis like this, we can actually calculate the specific coefficient between points A and B, and also between B and A, because the numbers going from A to B and B to A are a little bit different. We use something called the midpoint formula, so we don't get different elasticities from A to B and B to A. So quantity and percentage change. Midpoint formula, this kind of practice a little bit. The midpoint formula is going to use Q2 minus Q1, okay, over average Q. That's going to be essentially your percentage change in quantity. And we're doing the second quantity, okay, so we can kind of plug in what we had before. The second quantity was 12. The first quantity, I believe, was 5, okay, over the average. The reason we use the average is so that we can, create a consistent elasticity between points A and B and A. So the average between 12 and 5 is 8.5. Once I calculate that, so I'm going to get my little calculator here, okay? So I am going to allow you also to use a calculator. So 12 minus 5 divided by 8.5, okay, we have about 82%, give or take, is our percentage change in quantity. If you can do the middle school percentage change and you don't use the average of 8.5, like Q2 minus Q1 over Q2, that is fine also. The AP folks are not going to hold you accountable to the specific numbers, but you may see the midpoint formula, and there's other ways to determine elasticity too. This is most typical. Quantities in the numerator, we only have quantity, so of course we need percentage change in price. And before, with the graph that we did, you could kind of see the demand curve that the price was decreasing from point A to point B, and the quantity was increasing, let's say, from 5 to 12. And the price was decreasing from 10 to 5. So now we want to do the percentage change in price. It's going to be the exact same thing, except now with price, P2 minus P1 over average P, okay? So in this case, P2 was 5, okay? The second price was the lower price, 5 minus 10, and this is where we're going to get the negative number from, which makes sense because we're talking about the law of demand, and this is going to be 7.5, okay? So we can calculate that, and we're going to get it's about 66%, okay, or 0.82 and 0.66. If I was going to kind of pull out a coefficient here, I might get something like around 1.24, which is going to be my coefficient. Because this is greater than 1, I'm going to classify that anything greater than 1, where the percentage change in quantity is greater than the percentage change in price, that's going to be something that is elastic demand, okay? At least between those points A and B, okay? I will put up a practice problem for you in the next slide, where we can, and I'll leave it there so you can check this out, okay? In this case, you can certainly graph this, so you can see it graphically, and then you can also apply the midpoint formula. Midpoint formula is Q2 minus Q1 over average Q, okay, over P2 minus P1 over average average P, I'm sorry, and use, a calculator. This is going to give you percentage change in quantity, and you have to actually figure out the percentage change from your, whatever number that you're going to get in decimal form, and then the same thing with percentage change in price, okay? And remember, you're always going to have a negative number. Ignore the sign, okay? All right, be well, everybody. This was an intro, so I hope that it helped a little bit to get us started. Be well.